I'm grateful you joined tonight. Your brain is burning energy right now trying to force sleep, creating the very alertness that keeps you awake. You'll discover why exhaustion can paradoxically prevent rest and understand how your mind's desperate attempt to sleep becomes the barrier itself. Welcome to Psychology for Sleep. Wherever you are right now, perhaps lying in darkness, feeling bone-tired yet wide awake, muscles heavy, but thoughts racing. Allow yourself to rest in this confusing moment. We'll journey through 100 psychology facts about exhaustion's strange grip on consciousness. From the neural pathways that misfire when we're overtired, to the chemical confusion that keeps exhausted minds spinning, to the bridge between wanting sleep and allowing it to arrive. This thoughtful journey through consciousness builds bridges between searching minds. Your gentle support, a like, subscribe, or a quiet share, creates a pathway for more tired souls to discover and brings us closer to protect this sanctuary for every exhausted mind who finds their way here. One peaceful night, one sleepy soul at a time. Your healing journey inspires ours. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts about exhaustion drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into the peaceful fog of approaching sleep. Safe and undisturbed, close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Your brain enters a strange state when exhaustion meets sleeplessness. According to research from the National Institutes of Health, published in late 2024, this paradoxical state creates what neuroscientists call tired wired syndrome, where your body feels depleted but your mind races with unusual clarity. Brain imaging studies show that after roughly 16 to 20 hours of continuous wakefulness, the prefrontal cortex begins showing patterns of both hyperactivity and dysfunction simultaneously. This isn't a malfunction. It's your ancient survival system activating, interpreting extreme fatigue as a potential threat that requires heightened vigilance. Your exhausted brain, desperate to protect you, creates the very alertness that prevents the rest you so desperately need. The adenosine molecule is exhaustion's primary messenger. Throughout your waking hours, this compound accumulates in your brain like snow on a winter evening, creating what scientists call sleep pressure. Stanford's Sleep Sciences Center reveals that adenosine fundamentally alters how neurons communicate, binding to receptors and slowing neural firing to create that familiar heavy feeling. But when you're severely exhausted, adenosine levels become so elevated that they trigger compensatory mechanisms. Your brain releases counterchemicals, dopamine, norepinephrine, attempting to maintain function. These stimulating neurotransmitters clash with sleep signals, creating neurochemical confusion that feels like exhaustion and alertness occupying the same moment. Sleep scientists have identified what they call the exhaustion arousal cycle. Research from Harvard Medical School's Division of Sleep Medicine shows that extreme tiredness activates your brain's stress response system, your hypothalamic pituitary adrenal axis, the body's central stress mechanism. Interprets prolonged wakefulness as a survival situation requiring immediate attention. This system evolved millions of years ago when staying awake despite exhaustion might have meant escaping danger. Cortisol levels rise. Heart rate variability decreases. and your sympathetic nervous system engages. The more exhausted you become, the more your body believes something must be wrong, creating a continuous loop where the attempt to force sleep generates the very arousal that prevents it. Your ancient brain cannot distinguish between life-threatening wakefulness and simple insomnia. The default mode network reveals exhaustion's deepest secrets. This collection of brain regions becomes active when you're not focused on external tasks. During rest, daydreaming, or the transition to sleep. Studies published in Nature Neuroscience in early 2025 show that extreme exhaustion disrupts the default mode network's natural rhythm. Instead of settling into the gentle patterns that precede sleep, the network shows erratic, unpredictable activity. Thoughts begin to fragment and reassemble in unusual ways. Your exhausted mind starts generating intrusive thoughts, replaying conversations, creating anxious scenarios. This isn't random mental noise. It's your default mode network struggling to process the day's experiences without sufficient resources. Like an overloaded computer attempting too many tasks simultaneously. The harder you try to quiet these thoughts, the more processing power you dedicate to the effort, paradoxically increasing activity in regions that should be settling towards sleep. Your body's circadian rhythm and sleep pressure operate as separate systems. The two-process model of sleep regulation, refined through decades of research, explains why exhaustion doesn't guarantee sleep. Process S represents sleep pressure, that adenosine accumulation we discussed. Process C represents your circadian timing system, governed by your suprachiasmatic nucleus responding to light and darkness. Recent findings from the Society for Research on Biological Rhythms demonstrate that these systems can fall catastrophically out of sync. You might feel exhausted. Process S maxed out, while your circadian system signals it's time for alertness. This misalignment commonly occurs in shift workers, travelers crossing time zones, and anyone experiencing chronic stress. Your body displays all the physiological markers of exhaustion, while your internal clock insists it's mid-afternoon, creating a neurobiological tug-of-war that leaves you suspended between wakefulness and sleep, belonging fully to neither state. The amygdala becomes hyperreactive when you're severely tired. This almond-shaped structure processes emotions, including fear and responses to uncertainty. Research from UC Berkeley's Sleep and Neuroimaging Lab shows that after approximately 24 hours of sleep deprivation, amygdala activity can increase by 60% or more when viewing emotional images. But the connection to the prefrontal cortex, which normally regulates emotional responses, weakens significantly. This means your exhausted brain perceives threats more intensely while simultaneously losing its ability to rationalize and calm those reactions. That's why minor concerns transform into catastrophic worries late at night. Your overworked amygdala sounds alarm bells that your depleted prefrontal cortex cannot properly evaluate or silence. Every small worry becomes amplified, creating a cascade of responses to uncertainty that further prevents sleep. The exhaustion that should make you drowsy instead makes you emotionally vulnerable and hypervigilant. Muscle tension creates ongoing patterns with mental exhaustion. Studies from the American Academy of Sleep Medicine reveal that physical fatigue triggers subtle but persistent muscle-bracing patterns. When you're exhausted but can't sleep, your body enters what researchers call vigilant resting. Muscles maintain low-level tension, as if preparing to respond to threats. Your jaw might clench slightly. Shoulders rise a fraction of an inch Hands form loose fists. This tension sends signals back to your brain, indicating that rest hasn't truly been achieved, that some danger requires continued readiness. Your exhausted muscles, too tired to fully relax, maintain just enough activation to convince your nervous system that complete surrender to sleep would be unsafe. Each tense muscle fiber becomes a tiny voice arguing against the sleep your body desperately needs, creating a conversation between body and mind where both sides speak but neither listens. Temperature regulation becomes impaired during extreme exhaustion. Your core body temperature naturally drops as bedtime approaches, signaling to your brain that sleep is appropriate. But research published in the Journal of Clinical Sleep Medicine shows that chronic exhaustion disrupts this thermoregulatory pattern. Your hypothalamus, the brain region controlling temperature, struggles to maintain the precise cooling curve needed for sleep initiation. You might feel simultaneously too hot and too cold, throwing off blankets only to pull them back moments later. This temperature instability stems from depleted metabolic resources and stress hormone interference. Your body cannot efficiently redistribute heat from core to periphery, the process that normally facilitates sleep onset. Without proper cooling signals, your brain remains uncertain whether conditions are appropriate for sleep, maintaining a state of uncertain wakefulness despite overwhelming fatigue. The reticular activating system holds the keys to consciousness itself. This network of neurons in your brainstem regulates the transition between wakefulness and sleep, functioning like a neurological dimmer switch. Recent research from Johns Hopkins shows that severe exhaustion can paradoxically increase activity in this system. When you're extremely tired, the reticular activating system receives conflicting information. Sleep pressure signals say, shut down, but stress hormones and metabolic confusion say, stay alert. The system responds by increasing its baseline activity level, like turning up a radio's volume to hear a weak signal better. This heightened activity maintains consciousness when your body should be surrendering to sleep. Your brainstem, trying to resolve contradictory information, chooses vigilance over rest, an evolutionary safe choice when resources are limited and the environment might be dangerous. But exactly the wrong response when you're simply lying in a safe bedroom, desperate for sleep. So yes, exhaustion is already changing our understanding of sleep by showing us that tiredness and sleepiness are not the same state. Exhaustion represents depleted resources, empty fuel tanks, overworked systems, accumulated metabolic waste. Sleepiness represents your brain's readiness to enter the sleep state. Proper timing, appropriate neurochemical balance, sufficient sense of safety. You can be exhausted without being sleepy, creating the maddening experience of lying in darkness, feeling utterly drained yet completely awake. This distinction helps explain why trying harder to sleep fails so spectacularly. Exhaustion is a physiological state. Sleep is a neurological process. Confusing the two is like expecting a car to start just because it needs fuel. The recognition that exhaustion can actually prevent sleep represents a fundamental shift in how we understand rest and recovery. Your eyes reveal exhaustion's grip on consciousness. Pupil behavior provides a window into your brain's arousal state. Studies using infrared pupillometry show that exhausted individuals display unusual pupil patterns, rapid fluctuations between dilation and constriction, indicating unstable arousal levels. Your pupils should gradually constrict as you become drowsy, reflecting decreased norepinephrine activity in your locus coeruleus. But when exhaustion meets sleeplessness, pupils show what researchers call fatigue fighting patterns, erratic changes, suggesting your brain is oscillating between shutdown attempts and arousal surges. Each pupil dilation represents a micro-moment where your brain reactivates arousal systems, fighting against the exhaustion trying to pull you under. These tiny eye muscles, controlled by deep brain structures, tell the story of an internal war between rest and vigilance, played out dozens of times each minute in the darkness of your bedroom. Memory consolidation processes become desperate when you're exhausted. Your hippocampus, which processes daily experiences into long-term memories, requires sleep to function properly. Research from MIT's Picard Institute shows that extreme exhaustion creates a backlog of unprocessed experiences. Your brain attempts to consolidate memories during quiet, waking moments, generating random thought fragments, image flashes, and emotional replays. This explains why exhausted minds wander through disconnected memories. Your hippocampus trying to clear its processing queue without the deep sleep stage it needs. These intrusive memories aren't random. They're your brain's desperate attempt to maintain cognitive function despite impossible conditions. Each memory fragment that surfaces represents your exhausted hippocampus crying out for the sleep that would allow proper processing, creating mental noise that ironically prevents the very state needed for resolution. Your gut-brain axis contributes to exhaustion's complexity. The enteric nervous system, sometimes called your second brain, contains hundreds of millions of neurons communicating with your central nervous system. Recent research published in Cell Metabolism reveals that exhaustion disrupts the gut microbiome's circadian rhythms. Certain bacterial species that should be dormant at night remain active, producing metabolites that influence brain function. Your gut bacteria generate neurotransmitter precursors, including those for serotonin and GABA. When exhaustion throws off their timing, these chemical signals arrive at wrong moments, potentially contributing to that wired but tired feeling. Your digestive system, trying to maintain its own rhythms despite the chaos in your brain, sends confusing signals upward through the vagus nerve. The exhaustion you feel isn't just in your head. It's a whole body phenomenon involving trillions of microorganisms trying to coordinate with a host whose timing signals have become unreliable. The anterior cingulate cortex acts as exhaustion's conflict monitor. This brain region detects when different neural systems generate contradictory signals. Functional MRI studies show that in exhausted but alert states, the anterior cingulate shows unusually high activity, suggesting it's working overtime to resolve the conflict between fatigue and wakefulness. This region essentially asks, should we be awake or asleep over and over, detecting the mismatch but unable to resolve it. Each detection of conflict triggers slight arousal, preventing the gradual descent into sleep. Your anterior cingulate, trying to make sense of impossible contradictions, maintains heightened activity that ironically perpetuates the very conflict it's attempting to resolve. This neural system, designed to help you navigate conflicting information, becomes part of the problem when exhaustion and alertness coexist in paradoxical combination. Blood flow patterns reveal exhaustion's neurological signature. Studies using arterial spin labeling MRI demonstrate that extreme tiredness creates unusual cerebral perfusion patterns. Some brain regions show decreased blood flow consistent with fatigue, while others, particularly in the frontal and parietal areas, show increased flow, suggesting heightened activity. This patchy, inconsistent perfusion pattern means different parts of your brain exist in different states simultaneously. Your visual cortex might be shutting down while your worry circuits activate. Your motor areas rest while your rumination networks accelerate. This neurological patchwork creates the strange phenomenology of exhausted wakefulness, feeling simultaneously dull and sharp, sleepy and alert, ready to collapse, yet unable to let go. Your brain's blood supply, trying to support conflicting demands with limited resources, creates a state of partial consciousness, unlike either full wakefulness or true drowsiness. The thalamus serves as exhaustion's overwhelmed gatekeeper. This central structure filters sensory information, deciding what reaches conscious awareness. Under normal conditions, the thalamus reduces sensory transmission as you approach sleep, creating that muffled, distant feeling. But research from Washington University shows that severe exhaustion impairs thalamic filtering. You become paradoxically more sensitive to minor sounds, light changes, and physical sensations. That ticking clock you never notice becomes amplified. Sheet texture feels irritating. Your partner's breathing sounds impossibly loud. Your exhausted thalamus, lacking resources for proper filtering, allows sensory information through that should be blocked. Each sensation that reaches awareness triggers slight arousal, creating an ongoing pattern where your overloaded gatekeeper fails to protect you from the stimulation, preventing sleep. The exhaustion that should dampen sensory awareness instead creates hypersensitivity to every input. Interoception, your awareness of internal body states, intensifies during exhausted wakefulness. The insula, a brain region processing bodily sensations, shows altered activity patterns when you're overtired. Recent studies indicate that exhaustion heightens awareness of heartbeat, breathing, and other normally unconscious processes. You begin noticing your heart rate's natural variability, interpreting normal fluctuations as signs of concern. Your breathing rhythm, usually automatic, suddenly requires conscious attention. Each swallow becomes noticeable. This heightened interoception creates what researchers call somatic hypervigilance. Your exhausted brain, unable to maintain normal filtering, amplifies awareness of internal sensations. These sensations, now in conscious awareness, demand attention and interpretation. Your mind creates explanatory narratives. Why is my heart beating this way? Is my breathing wrong? Each question generates slight responses to uncertainty, further preventing sleep. Your body's normal operations, brought into consciousness by exhaustion, become objects of worry rather than the background hum of healthy function. Sleep-onset dreams reveal exhaustion's liminal state. Hypnagogia, the transitional state between wakefulness and sleep, becomes prolonged and strange when you're exhausted but alert. Studies using high-density EEG show that overtired individuals spend extended periods in this borderland, experiencing vivid mental imagery without fully entering sleep. You might see faces forming in darkness, hear voices speaking nonsense, or feel sensations of falling or floating. These aren't hallucinations. They're your brain's dream generation systems, activating prematurely, trying to initiate sleep sequences without proper conditions being met. Each hypnagogic event briefly pulls you towards sleep, only to be interrupted by arousal systems responding to the unusual mental content. Your exhausted consciousness hovers in this strange space, too tired to maintain full wakefulness, but too activated to surrender to sleep, experiencing fragments of dreams that cannot complete their purpose of transitioning you to unconsciousness. The locus coeruleus holds exhaustion's secret trigger. This tiny cluster of neurons in your brainstem produces most of your brain's norepinephrine, the neurotransmitter maintaining alertness. Research published in Science Advances shows that the locus coeruleus displays paradoxical activity during exhausted wakefulness. Instead of the low, steady firing that permits sleep, it shows irregular bursts, brief volleys of activity followed by abnormal pauses. Each burst releases norepinephrine throughout your brain, creating micro-moments of alertness that reset your progress towards sleep. This irregular firing pattern stems from conflicting inputs. Adenosine signals saying rest, stress hormones saying stay alert, and circadian factors adding their own timing cues. Your locus coeruleus, receiving contradictory instructions, produces erratic output that maintains consciousness through sheer inconsistency. The exhaustion that should silence this arousal center instead creates unstable activity patterns that prevent the sustained quiet needed for sleep initiation. Glucose metabolism reveals why exhaustion impairs sleep-generating systems. Your brain, representing just 2% of body weight, consumes 20% of your glucose supply. PET scan studies show that prolonged wakefulness depletes glucose preferentially in regions responsible for sleep initiation. The ventrolateral preoptic area, your brain's sleep switch, requires adequate energy to actively inhibit arousal systems. When glucose levels drop due to exhaustion, this sleep-promoting region cannot generate sufficient inhibitory signals. Meanwhile, more primitive arousal systems, designed to function during energy scarcity, maintain activity. This creates metabolic imbalance, where wake-promoting systems overpower weakened sleep-promoting circuits. Your exhausted brain lacks the fuel to activate the very mechanisms that would restore energy through sleep. It's a cruel metabolic trap. You need sleep to restore energy, but you need energy to initiate sleep. Each hour of wakefulness deepens this deficit, making the exhausted but alert state increasingly difficult to escape. These patterns reveal that consciousness is not what we thought. The boundary between wakefulness and sleep isn't a simple switch, but a complex negotiation between dozens of neural systems, each with its own logic and timing. Exhaustion disrupts this negotiation, creating states our ancestors rarely experienced. Prolonged wakefulness in safe environments, combined with chronic stress, artificial light, and metabolic confusion. Our brains evolved sleep-wake systems for a world where exhaustion typically meant genuine danger or extreme physical exertion, requiring vigilance. They didn't evolve for modern exhaustion, stress-induced, metabolically complex, occurring in completely safe bedrooms. Understanding this mismatch helps explain why exhaustion fails to guarantee sleep and why our intuitive approaches, trying harder, forcing rest, so often fail. The orexin system adds another layer to exhaustion's puzzle. Orexin neurons, located in the lateral hypothalamus, promote wakefulness and stabilize arousal states. Studies from Stanford University show that stress and exhaustion can trigger sustained orexin release. Even when sleep pressure is high, these neurons respond to emotional significance and potential threats, remaining active when your brain interprets the environment as requiring vigilance. In prehistoric contexts, this made sense. Stay alert despite exhaustion when predators might be near. In modern bedrooms, this same system activates in response to work stress, relationship concerns, or even worry about not sleeping. Your orexin neurons, reading emotional arousal as potential danger, release wake-promoting signals that override fatigue signals. Each worried thought reinforces their activity, creating a state where exhaustion coexists with neurochemically enforced wakefulness. The more you need sleep, the more threatening sleeplessness feels, creating the exact emotional arousal that prevents rest. Microarousals fragment the boundary between waking and sleeping. Sleep studies using polysomnography reveal that exhausted individuals experience frequent brief awakenings, lasting just seconds, that don't register in conscious memory. Your brain might transition towards sleep dozens of times each hour, only to spike back to wakefulness before the transition completes. Each microarousal represents a failed sleep attempt, often triggered by subtle changes. A thought fragment, muscle twitch, breathing irregularity, or environmental stimulus. The accumulation of these failed attempts creates subjective insomnia despite spending hours in bed with eyes closed. Your exhausted brain keeps trying to initiate sleep but cannot maintain the stable conditions needed for the transition to complete. It's like repeatedly attempting to start a car with a weak battery. Each attempt draws down resources, making subsequent attempts less likely to succeed. The effort itself becomes the obstacle. The parasympathetic nervous system struggles to engage during exhausted wakefulness. This rest and digest branch of your autonomic system should gradually dominate as bedtime approaches, slowing heart rate, promoting digestion, and preparing your body for sleep. But research shows that chronic stress and exhaustion impair parasympathetic activation. Your vagus nerve, the primary parasympathetic pathway, shows reduced tone, meaning it cannot effectively counterbalance sympathetic arousal. Your heart rate variability decreases, indicating reduced parasympathetic influence. Your body remains in a mixed state, too tired to be fully alert, too activated to rest. This autonomic imbalance explains why breathing exercises and relaxation techniques sometimes fail when you're extremely exhausted. You're not doing the techniques wrong. Your parasympathetic system simply lacks the capacity to generate adequate responses. The exhaustion that should naturally promote rest instead depletes the very systems responsible for creating restful states. And so we see that exhaustion doesn't simply make you tired. It creates a unique neurobiological state where multiple systems fall out of their normal synchronization. Still scientific, but the pattern is becoming clear. The harder you try to force sleep when genuinely exhausted, the more you activate arousal systems designed to interpret sleep resistance as danger requiring continued vigilance. Your evolutionary mechanisms, unable to distinguish between genuine threats and benign sleeplessness, choose wakefulness as the safer option. Understanding this helps explain why paradoxical intention, giving up trying to sleep, sometimes works when you stop interpreting wakefulness as threatening You remove the emotional arousal that activates orexin neurons, reduces anterior cingulate conflict detection, and allows your locus coeruleus to settle into regular patterns. The exhaustion remains, but without the layered arousal that transforms fatigue into sleepless vigilance. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence. Heart beating, lungs breathing, brain thinking, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-balancing. Now we continue. Cortisol follows a daily rhythm that exhaustion disrupts. Normally, this stress hormone peaks around waking time, providing energy for the day, then gradually declines toward bedtime. Studies from the Max Planck Institute show that chronic exhaustion flattens this curve. Your bedtime cortisol remains elevated, creating a chemical environment incompatible with sleep. This doesn't happen immediately. Repeated nights of poor sleep gradually reprogram your hypothalamic pituitary adrenal axis. Your body learns to expect nighttime wakefulness and adjusts cortisol production accordingly, creating a self-reinforcing pattern. Each night of exhausted wakefulness teaches your stress system to maintain vigilance during hours that should be restful. Breaking this pattern requires time and consistency, retraining your endocrine system to recognize night as genuinely safe. Melatonin production can become impaired by exhaustion itself. This hormone, produced by your pineal gland in response to darkness, promotes sleepiness under normal conditions. But research indicates that chronic stress and adrenal fatigue can suppress melatonin synthesis. Your pineal gland requires adequate serotonin, the precursor to melatonin, and specific enzyme systems that exhaustion may impair. Additionally, even small amounts of light exposure reset melatonin production, and exhausted individuals often check phones or turn on lights during sleepless nights, further disrupting synthesis. Your body might be producing only a fraction of the melatonin needed for robust sleep drive, creating a chemical state where darkness triggers little drowsiness. The exhaustion that should enhance sleep drive instead interferes with the hormonal systems that translate darkness into sleepiness. GABA, your brain's primary inhibitory neurotransmitter, reveals exhaustion's chemical contradictions. This molecule quiets neural activity, essential for sleep initiation. Studies using magnetic resonance spectroscopy show that exhausted individuals often have reduced GABA levels in key brain regions. Paradoxically, your GABAergic neurons become depleted through overwork. They've been trying to calm your overactive mind for hours or days, gradually exhausting their own resources. Lower GABA means reduced inhibitory tone, allowing excitatory neural activity to dominate. Your brain loses its ability to quiet itself, like a car with failing brakes. Each worried thought cascades into more activity because the chemical systems that would normally dampen neural firing have become depleted. Exhaustion reduces the very neurotransmitter that permits rest, creating a state where tiredness paradoxically increases brain activity. Histamine operates as an alertness signal that exhaustion can inappropriately activate. The tuberomammillary nucleus in your hypothalamus releases histamine to maintain wakefulness. Normally, this system quiets at night, but research shows that stress and exhaustion can maintain its activity. Inflammatory processes triggered by chronic stress and inadequate sleep increase histamine release throughout your body and brain. This creates low-grade allergic-like responses that promote wakefulness. Some people with chronic insomnia show elevated nighttime histamine despite feeling exhausted. This explains why some individuals find antihistamines somewhat helpful for sleep. They're not just feeling drowsy as a side effect. They're blocking an alertness signal that shouldn't be active at bedtime. Your exhausted body, experiencing stress as a form of internal threat, maintains inflammatory vigilance that includes histamine release, creating wakefulness through immune pathways. Serotonin's dual role in sleep regulation reveals exhaustion's complexity. This neurotransmitter promotes wakefulness in certain brain regions while serving as melatonin's precursor in your pineal gland. Studies show that exhaustion can skew serotonin toward wake-promoting functions, reduced tryptophan availability due to stress-altered metabolism, may preferentially affect melatonin synthesis, while leaving wake-promoting serotonergic neurons relatively functional. Your dorsal raphe nucleus, containing most serotonergic neurons, shows altered firing patterns during exhausted wakefulness. These neurons should be quiet at night, but stress-related inputs can maintain their activity. Each serotonergic firing prevents your thalamus from entering the gating mode necessary for sleep. Your exhaustion affects not just serotonin levels, but how your brain allocates this limited resource between competing functions. Dopamine dysregulation contributes to exhaustion's paradoxical alertness. This neurotransmitter, associated with motivation and reward, should follow daily patterns with lower nighttime levels. Research from the NIMH demonstrates that chronic stress and poor sleep create dopamine imbalances. Your ventral tegmental area and substantia nigra, key dopamine-producing regions, may show altered activity patterns. Some exhausted individuals experience low motivation alongside inappropriate evening alertness, suggesting dopamine is available at wrong times. This misallocation stems from disrupted circadian regulation of dopamine-producing neurons. Your brain attempts to generate energy and focus despite exhaustion by releasing dopamine, creating artificial alertness that prevents natural sleep. It's like drinking coffee when exhausted. Temporarily effective, but ultimately counterproductive. Your dopamine system, trying to help you function despite impossible conditions, creates the wakefulness preventing the recovery that would restore normal function. Adenosine receptor sensitivity changes with chronic exhaustion. We discussed adenosine accumulation earlier, but receptor responsiveness matters equally. Studies suggest that prolonged poor sleep may affect adenosine receptor sensitivity. Your neurons might reduce the number of receptors or decrease their responsiveness, requiring more adenosine to generate the same sleepiness. This adaptation makes sense in evolutionary terms. If sleep isn't happening, reducing sensitivity to sleep signals allows continued functioning. But this creates a difficult situation. Your sleep pressure increases, but your brain's ability to detect that pressure decreases. You need more and more adenosine to feel sleepy. But adenosine levels can only rise so high before causing other problems. This receptor adaptation, meant to help short-term survival during temporary sleep loss, becomes a long-term problem when exhaustion persists night after night. Inflammatory cytokines link exhaustion to immune system confusion. Sleep deprivation triggers release of pro-inflammatory molecules like interleukin-6 and tumor necrosis factor alpha. These immune signaling molecules normally help fight infection, but chronic elevation affects brain function. Research shows that inflammatory cytokines can paradoxically promote both fatigue and wakefulness. They create feelings of exhaustion and malaise while simultaneously activating arousal systems. Your immune system, interpreting chronic wakefulness as a form of threat or illness, maintains inflammatory vigilance. This explains why exhausted individuals often feel physically ill, slightly feverish, mentally foggy. Your body has activated illness response behaviors, which include altered sleep patterns. The exhaustion you feel isn't purely neural. It includes genuine immune system activation that creates its own sleep-disrupting consequences. Neuropeptide Y adds complexity to exhaustion's chemical landscape. This molecule regulates appetite, stress response, and circadian rhythms. Studies indicate that chronic stress and exhaustion alter NPY levels and timing. NPY typically promotes relaxation and can facilitate sleep, but its release patterns become disrupted when you're chronically exhausted. Your arcuate nucleus, which produces NPY, receives inputs from stress systems that can override normal circadian control. Some research suggests exhausted individuals show blunted NPY responses, reducing its calming effects. Your brain loses access to this natural anti-stress molecule precisely when you need it most. The exhaustion that should trigger compensatory calming mechanisms instead impairs those very mechanisms, creating a biochemical state where natural recovery systems cannot engage properly. Acetylcholine transitions between promoting alertness and enabling REM sleep. This neurotransmitter's complex role reveals exhaustion's impact on sleep architecture. Your basal forebrain produces acetylcholine that maintains waking attention, but your brainstem's cholinergic neurons are crucial for REM sleep. Research shows that exhaustion can disrupt this delicate balance. Your waking acetylcholine systems might remain too active at night, preventing sleep initiation. Even if you do sleep, altered acetylcholine patterns can fragment sleep architecture, increasing REM pressure that manifests as vivid, sometimes intense dreams upon finally sleeping. Your exhausted brain struggles to properly transition acetylcholine functions from waking attention to dream facilitation, creating sleep that feels unrestful even when it occurs. The neurotransmitter that should smoothly transition between states instead gets stuck in patterns that maintain partial wakefulness. New understanding emerges. The problem isn't too little of sleep chemicals or too much of wake chemicals. The problem is timing and coordination. Every neurotransmitter and hormone exists in dynamic balance with others, following circadian rhythms and responding to immediate needs. Exhaustion doesn't simply tilt these balances. It destroys the timing relationships between them. You might have adequate melatonin, but elevated cortisol cancels its effects. Sufficient GABA, but excessive histamine overpowers its calming influence. The issue isn't the absolute level of any single chemical, but the loss of orchestrated timing between dozens of systems that normally rise and fall in precise coordination. Your exhausted brain has the chemical ingredients for sleep, but has lost the recipe. The precise sequence and ratios that transform individual molecules into the coordinated state we call sleepiness. Endorphins and dynorphins, your brain's natural opioids, play unexpected roles in exhausted wakefulness. These peptides typically reduce pain and create euphoria. but they also influence sleep-wake regulation. Studies show that chronic stress alters endogenous opioid systems. Your periaqueductal gray and other regions release these molecules in response to the distress of sleeplessness, creating a mild analgesic effect that might reduce motivation to change behaviors, perpetuating the problem. Some researchers hypothesize this represents an adaptive response. If sleep isn't available, make wakefulness more tolerable. Your brain, unable to solve the sleep problem, adjusts neurochemistry to make sleep loss less aversive. This biochemical resignation helps explain why some chronic insomniacs report feeling strangely wired or even mildly euphoric during late-night wakefulness. Their opioid systems have adapted to make the impossible situation more bearable. Oxytocin, typically associated with bonding and trust, affects sleep through unexpected mechanisms. This neuropeptide promotes relaxation and has mild sedative effects. Research indicates that social stress and exhaustion can impair oxytocin signaling. Your paraventricular nucleus normally releases oxytocin in patterns that support sleep, but chronic activation of stress systems reduces this release. Additionally, oxytocin receptor expression may decrease with prolonged stress. This means exhausted individuals lose access to oxytocin's calming effects, making it harder to feel safe and relaxed enough for sleep. The social buffering effect, feeling calmer near trusted others, depends partly on oxytocin. Exhausted individuals often withdraw socially, reducing opportunities for oxytocin release, creating another self-reinforcing cycle. Your body's natural bonding and calming chemistry becomes less available precisely when chronic stress makes these effects most needed. Galanin influences both sleep promotion and appetite regulation. This neuropeptide, produced in your hypothalamus, typically increases during sleep and promotes certain sleep stages. Studies show that exhaustion and metabolic stress affect galanin systems. Your ventrolateral preoptic area uses galanin as one of its sleep-promoting signals. But chronic stress can reduce galanin production or receptor sensitivity. Additionally, altered galanin contributes to the appetite changes commonly seen with sleep deprivation, explaining why exhausted people often crave specific foods. Your brain, lacking adequate galanin for sleep promotion, may generate compensatory food-seeking behaviors, attempting to restore balance through metabolic means. The exhaustion affects not just your ability to sleep, but your entire regulatory system, creating cravings and behaviors that seem unrelated but stem from the same neurochemical dysregulation. At this midpoint, the evidence is clear. Exhaustion creates not a simple chemical deficit, but a systems-level desynchronization. Every molecule we've discussed follows circadian patterns, responds to homeostatic pressure, and interacts with dozens of other systems. Exhaustion doesn't simply reduce sleep chemicals. It scrambles the timing, disrupts the ratios, and impairs the regulatory systems that normally maintain balance. Your brain becomes like an orchestra, where each musician plays correct notes but at wrong times, following different conductors. The resulting cacophony bears no resemblance to the symphony of coordinated systems that normally creates smooth transitions between wakefulness and sleep. Understanding this complexity explains why simple solutions rarely work and why recovery requires time. You're not just repleting depleted chemicals, but restoring intricate timing relationships between interdependent systems. You're still here with me, thoughts still flickering like candle light. Just notice. Don't judge. Just notice where your mind is. We are exploring consciousness itself, the very thing doing the exploring right now. Strange, beautiful, and perfectly calm. Let's drift onward together. Exhaustion teaches your brain that nighttime equals threat. Through a process called contextual conditioning, your bedroom becomes associated with frustration and vigilance, rather than safety and rest. Neuroscientists studying learned insomnia show that your amygdala and hippocampus form memories linking bed, darkness, and bedtime routines with the stress of sleeplessness. After multiple nights of exhausted wakefulness, simply entering your bedroom triggers subtle arousal. Your heart rate increases slightly. Stress hormones rise. Muscles tense. These physiological changes occur below conscious awareness, preparing you for the struggle you've learned to expect. Your exhausted brain, trying to predict and prepare for challenges, creates the very arousal that ensures those challenges materialize. Breaking this conditioning requires consistently pairing the bedroom with calm outcomes, a slow process of relearning that nighttime can be safe. Sleep effort becomes its own problem. Research on sleep performance worries reveals that the more you try to make yourself sleep, the more you activate executive control networks incompatible with sleep. Sleep, paradoxically, requires a kind of passive allowing rather than active achieving. Studies using neurofeedback show that the intention to sleep activates prefrontal regions that should be quieting. Each deliberate relaxation technique, each conscious breath, each mental strategy to induce sleep engages goal-directed thinking that prevents the default mode network from settling into sleep-compatible patterns. Your exhaustion creates desperate trying, and this trying activates precisely the control systems that must deactivate for sleep to occur. It's like trying to fall by jumping upward. The effort moves you in the opposite direction from your goal. The more exhausted you become, the more desperately you try, creating an ongoing pattern where increased effort guarantees continued wakefulness. Cognitive fusion with sleeplessness changes your identity. Acceptance and commitment therapy research shows that chronic exhaustion often leads to defining yourself through insomnia. You become an insomniac rather than someone currently experiencing sleep difficulties. This identity shift has neurological consequences. Your brain allocates attention and resources based on what you identify as important, creating what psychologists call selective attention. Once you identify as someone who cannot sleep, your brain prioritizes detecting evidence supporting this identity. You remember nights you couldn't sleep more than nights you did. You notice tiredness more than moments of energy. This cognitive bias maintains the problem by shaping your perception of reality. Your exhausted mind, seeking to create a coherent narrative of experience, adopts a story where sleeplessness is fundamental to who you are, making change seem impossible because it would require becoming a different person. Catastrophic thinking about sleep consequences amplifies exhaustion's effects. Studies on sleep-related cognitions reveal that believing sleep loss is catastrophic increases the physiological stress response. If you think I won't be able to function tomorrow, your body releases more cortisol and other stress hormones than if you think tomorrow might be harder but I'll manage. Your beliefs about sleep's importance directly influence your stress system's reactivity. Exhausted individuals often catastrophize, imagining the worst possible consequences of each sleepless night. These catastrophic thoughts aren't just distressing, They create genuine physiological arousal that prevents sleep. Your brain, convinced that sleep loss threatens survival, maintains vigilance to protect you from this perceived danger. The irony is perfect. Your effort to emphasize sleep's importance creates the very responses to uncertainty that prevents achieving it. The more you need sleep, the more threatening sleeplessness becomes, ensuring that sleep remains elusive. Hyperarousal develops as exhaustion becomes chronic. This isn't simply being alert. It's a sustained physiological state where multiple arousal systems maintain elevated baseline activity around the clock. Research using 24-hour physiological monitoring shows that chronic insomniacs display elevated metabolic rate, increased cortisol production, faster heart rate, and higher body temperature even during daytime rest. Exhaustion, rather than reducing arousal, seems to increase it. Your body, interpreting chronic wakefulness as ongoing emergency, maintains a state of readiness that makes rest physiologically difficult. This hyperarousal persists even when you're not actively trying to sleep. It becomes your baseline state. Recovery requires not just getting tired enough to sleep, but gradually down-regulating these overactive arousal systems. A process that takes time and cannot be rushed. The subjective experience of time distorts during exhausted wakefulness. Minutes feel like hours as you lie in darkness monitoring your continued consciousness. This temporal dilation stems from how your brain processes duration. By counting events and changes, during normal sleep approach, fewer mental events occur, making time seem to pass quickly. But exhausted wakefulness generates constant mental activity. Thoughts, worries, physical sensations, providing abundant events for your brain to count. Each event makes time feel longer. Studies show that insomniacs often overestimate time spent awake. But this isn't simply misperception. Your subjective experience of duration is genuinely extended because your mind generates more measurable moments. This temporal distortion increases suffering by making each sleepless night feel endless, further reinforcing beliefs about sleep being impossible and creating more responses to uncertainty for future nights. Emotional regulation deteriorates as exhaustion persists. Brain imaging studies show that sleep deprivation impairs connections between the amygdala and prefrontal cortex, reducing top-down control of emotions. Small frustrations trigger disproportionate reactions. Minor disappointments feel devastating. This isn't weakness or character failure. It's predictable neurological change from sustained wakefulness. Your exhausted prefrontal cortex cannot generate sufficient inhibitory signals to moderate emotional responses. You might cry at commercials, snap at loved ones, or feel overwhelming sadness about situations you'd normally handle calmly. These emotional swings create additional stress, further activating arousal systems and perpetuating sleeplessness. Your exhaustion impairs the very emotional regulation skills you need to cope with sleeplessness, creating another self-perpetuating cycle. Each emotional overreaction generates shame and worry, adding more arousal and making sleep even less likely. Attention becomes both impaired and hyper-focused during exhaustion. Your ability to concentrate on chosen tasks decreases. Your mind wanders. You reread paragraphs without comprehending. Conversations feel difficult to follow. Yet, paradoxically, you can become intensely focused on specific concerns, ruminating for hours on problems or replaying conversations obsessively. Research shows this reflects damaged attentional control rather than contradictory states. Your dorsal attention network, which directs focus voluntarily, becomes impaired. Meanwhile, your ventral attention network, which captures attention automatically for salient stimuli, remains active. You lose the ability to choose where attention goes while retaining involuntary capture by emotionally relevant content. Your exhausted mind can't focus on boring tasks, but can't stop focusing on worries, creating the worst of both worlds. Poor concentration when you need it. Locked attention on distressing content when you want distraction. Social cognition suffers under exhaustion's weight. Your ability to read facial expressions, interpret tone of voice, and understand others' mental states depends on neural systems that require adequate sleep. Studies show that exhausted individuals misinterpret neutral faces as threatening, miss social cues, and struggle to take others' perspectives. This social cognitive impairment damages relationships precisely when you need social support most. You might withdraw, convinced others don't understand, when really your impaired social cognition prevents recognizing their genuine concern. Or you might misinterpret neutral comments as criticism, creating conflicts that generate more stress. Your exhaustion impairs the social skills that could help you access support and connection, isolating you within your struggle. The loneliness this creates feeds back into stress systems, creating more arousal and worsening sleep problems. Halfway through this exploration, fundamental implications become clear. Exhausted wakefulness isn't simply tiredness plus insomnia. It's a distinct state with its own psychology, physiology, and self-perpetuating mechanisms. Understanding this helps explain why standard advice often fails. Just relax doesn't work when arousal systems are physiologically locked in hypervigilance. Try harder activates executive control incompatible with sleep. Don't worry about it fails when catastrophic thinking has become automatic. The exhaustion you feel doesn't represent a simple problem requiring a simple solution. It represents a complex systems failure affecting dozens of interrelated processes. This complexity isn't discouraging. It explains why quick fixes fail and validates the struggle you've experienced. Recovery isn't about finding the one right trick, but about gradually restoring balance to multiple dysregulated systems. A process requiring patience, self-compassion, and time. Let each breath guide you to realize time is yours, a separate stream that only you are living, while the vast universe continues to spin, expand, change. This second you're breathing, listening, is unique. Cherish the present moment, knowing that right now, your time is unique in the universe, and we continue drifting. Your nervous system exists in states, not switches. Sleep researchers increasingly describe consciousness as existing along a continuum rather than in distinct categories. You're not simply awake or asleep, but in complex states involving dozens of variables. Arousal level, attention, sensory processing, memory formation, emotional tone. Exhausted wakefulness represents a state where many variables sit in contradictory positions. High arousal, but low attention. Elevated sensory sensitivity, but poor information processing. Strong emotional reactivity, but weak emotion regulation. This state cannot be easily categorized, which explains why it feels so strange and why conventional approaches developed for normal insomnia may not apply. Your mind occupies a space on the consciousness continuum where few people spend prolonged time. A unique zone where exhaustion meets arousal, in configurations our language struggles to describe. The body keeps the score, holding exhaustion in muscles and fascia. Somatic experiencing research reveals that chronic stress stores in physical tissue as persistent tension patterns. Your shoulders might permanently rise. Jaw remain clenched even during supposed relaxation. Breathing becomes shallow without conscious awareness. These holding patterns aren't just symptoms of stress. They actively perpetuate it through bottom-up signaling. Your tense muscles send danger signals to your brain, maintaining arousal even when no external threat exists. Years of exhausted wakefulness can create structural changes in muscle tissue, shortened fibers, altered fascia, that maintain tension even after psychological stress resolves. True recovery requires addressing this somatic component, gradually releasing held patterns through patient, consistent work. Your body remembers every exhausted night, storing the memory in tissue. And releasing these memories takes time. Chronotype mismatch intensifies exhaustion's effects. Your genetic predisposition toward morning or evening alertness, your chronotype, conflicts with social and work schedules for many people. Studies show that evening chronotypes forced into early schedules experience chronic sleep deprivation that exacerbates vulnerability to exhausted wakefulness. Your circadian system generates alertness and sleepiness signals at times that conflict with when you're trying to sleep. This isn't a disorder requiring treatment. It's a mismatch between your biology and your schedule. But the chronic sleep debt created by this mismatch makes you more susceptible to the arousal and cognitive patterns maintaining exhausted wakefulness. Your body. Trying to sleep at times your genetics say you should be alert, faces an additional challenge beyond whatever psychological or environmental factors contribute to sleeplessness. Dreams attempt to process exhaustion's emotional residue. When you finally sleep, your REM periods become intense, sometimes disturbing, as your brain attempts to process accumulated emotional content. Research on REM rebound shows that sleep-deprived individuals show increased REM density and intensity, experiencing vivid, sometimes intense dreams. These aren't random. They represent your hippocampus and amygdala working overtime to process experiences that should have been gradually integrated each night. The dreams can be so intense, they create responses to uncertainty about sleeping, adding another layer to the problem. Your sleeping brain, overwhelmed by backlogged emotional processing, generates intense content that makes sleep feel threatening rather than restorative. This explains why some exhausted people report fearing sleep, knowing it will bring difficult dreams rather than peaceful rest. Window of tolerance describes your nervous system's flexibility range. Polyvagal theory explains that you have an optimal zone where you can respond flexibly to stress and return to calm. Exhaustion narrows this window dramatically. Small stresses push you into hyperarousal or collapse. You have less buffer zone, less resilience. Situations you'd normally handle trigger dysregulation. This narrowed window makes everything harder. Managing emotions, tolerating discomfort, staying present. Recovery involves gradually expanding this tolerance window, building capacity to experience activation without spiraling into full arousal. Your exhausted nervous system has lost flexibility, becoming rigid and reactive. Restoring flexibility requires gentle exposure to manageable challenges, building confidence that your system can handle activation and return to baseline. This capacity cannot be forced or rushed. Interoceptive accuracy affects how you interpret exhaustion. Some people accurately sense their internal states, while others show poor body awareness. Research indicates that poor interoceptive accuracy, combined with high interoceptive attention, creates problematic patterns. You might monitor body sensations intensely but interpret them inaccurately, creating false alarms. That sensation might be normal drowsiness, but you interpret it as danger, triggering arousal. Or you might miss genuine sleep signals because you've learned to distrust body sensations. Exhaustion often impairs interoceptive accuracy while increasing attention to body signals, creating worst-case combination. You notice every sensation but cannot interpret them reliably, leading to constant misattribution and inappropriate responses. Improving sleep sometimes requires training more accurate body awareness, learning to distinguish genuine sleep signals from responses to uncertainty. Meaning-making transforms exhaustion from experience to identity. Humans are story-creating beings. We need narratives to make sense of experiences. Chronic exhausted wakefulness demands explanation. Your mind generates stories. I'm broken. Something's wrong with me. I'll never recover. These narratives aren't objectively true. They're meaning-making attempts. But once established, they shape perception and behavior. Studies on narrative therapy show that changing your relationship to these stories, seeing them as one possible interpretation rather than objective truth, can reduce their power. Your exhaustion remains real, but the story about what it means becomes flexible. This cognitive shift doesn't cure insomnia, but reduces the additional suffering created by believing catastrophic narratives about what sleeplessness means about you as a person. Titration and pendulation offer pathways through intense states. Somatic therapy uses these concepts for working with overwhelming experiences. Titration means experiencing challenges in small, manageable doses rather than all at once. Pendulation means alternating between activation and resource states, rather than staying stuck in arousal. Applied to exhaustion, this suggests approaching recovery gradually, not trying to fix everything immediately, but building capacity slowly. You might practice staying with mild tiredness without trying to force sleep, building tolerance for the uncomfortable sensation. Then shift attention to something neutral or pleasant, allowing your nervous system to experience that it can move between states. This gentle oscillation builds capacity for change without overwhelming your already stressed system. Recovery through titration and pendulation is slower, but more sustainable than dramatic interventions. Mirror neurons and social contagion affect sleep through unexpected routes. When you observe someone yawning or sleeping, mirror neuron systems activate similar patterns in your brain. This social dimension of sleep means isolation potentially worsens exhausted wakefulness. Watching others sleep peacefully could trigger your own sleep systems, but exhausted people often withdraw, losing this social entrainment. Conversely, high-stress social environments can entrain your nervous system toward activation. The people you spend time with influence your physiological state through mirror neuron activation and autonomic resonance. Your exhausted nervous system might benefit from carefully chosen social exposure. Being near calm, regulated people whose nervous systems can help regulate yours through unconscious social processes. This isn't about talking about sleep, but about absorbing regulatory capacity from others' calm presence. The pause between exhale and inhale holds unique properties. Respiratory physiology shows this natural pause, called the respiratory pause, correlates with increased parasympathetic tone. Your vagus nerve activity increases during this brief moment, before the next breath begins. Exhaustion often eliminates these pauses. Breathing becomes continuous, driven by responses to uncertainty, lacking the natural rhythm that supports parasympathetic dominance, gently allowing this pause to extend slightly. Not forcing breath retention, but simply noticing the natural rest between breaths, can help shift autonomic balance. This isn't a breathing technique requiring effort, but an awareness practice. Noticing something your body already does. Your exhausted nervous system might respond to this gentle attention. Using these micro moments of increased parasympathetic activity as starting points for larger shifts toward calm. We're reaching deeper understanding. Exhaustion maintains itself through multiple interlocking systems: chemical, physical, cognitive, emotional, social. Each system influences others in complex, ongoing patterns. Changing any single element provides limited benefit because other systems quickly compensate, restoring the familiar dysfunctional equilibrium. This explains why medications, therapy, supplements, or lifestyle changes often provide only partial help. Real recovery requires addressing multiple systems simultaneously, which seems overwhelming but actually offers hope. You have many entry points for change. Working with body through somatic practices, addressing cognition through mindfulness or therapy, adjusting social environment, normalizing circadian rhythms, supporting neurochemistry through nutrition and medication when appropriate. No single intervention needs to be perfect because changes in different domains support each other, gradually shifting the entire system toward healthier patterns. Surrender is not giving up, but changing effort's direction. Acceptance research in insomnia treatment shows paradoxical results. Accepting sleeplessness sometimes facilitates sleep while fighting. It maintains wakefulness. This seems backwards until you understand arousal systems. Fighting creates effort. Effort activates executive control. Executive control prevents sleep. Accepting doesn't mean liking or wanting the experience, but acknowledging its current reality without adding struggle. This reduces arousal just enough that natural sleep processes have opportunity to engage. Your exhaustion has taught you that trying harder doesn't work. What if trying differently works better? Not trying to make sleep happen, but trying to be present with whatever happens. This subtle shift in effort's direction, from achieving sleep to experiencing wakefulness, removes the performance worries, maintaining arousal. Neuroplasticity offers hope, but requires patience. Your brain can rewire itself, forming new connections and patterns. But this process is slower than we'd prefer. Research shows that consistent new behaviors create neural changes over weeks and months, not days. Each night you practice new approaches, whether that's better sleep hygiene, thought awareness, or somatic techniques, strengthens new pathways. Initially, these new pathways compete with established patterns. The old ways feel automatic and easy. New approaches require conscious effort, but persistence gradually shifts the balance. Old pathways, lacking reinforcement, weaken. New pathways, consistently activated, strengthen. Eventually, new patterns become automatic. Old patterns fade. Your exhausted brain can learn new ways of approaching nighttime. But the learning requires time and consistency rather than intensity. Patience becomes crucial, trusting that small changes compound over time. The peripheral nervous system influences the central system through afferent pathways. Most people think of nervous system control as top-down. Brain commands body. But 80% of vagus nerve fibers carry information from body to brain. Your intestines, heart, lungs send constant input upward, influencing emotional state and arousal level. This explains why body-based interventions can affect mental state. Changing your posture, breathing, muscle tension, or heart rate variability sends different signals to your brain, potentially shifting overall state. Your exhausted mind might resist cognitive interventions, but your body offers alternative pathways, working with physical state through gentle movement, body scan practices, or breathing. Accesses nervous system regulation through bottom-up rather than top-down routes. These approaches bypass the overthinking that maintains exhausted wakefulness. Now we understand that exhaustion-related wakefulness represents nervous system dysregulation rather than simple sleep debt. You're not just tired. Your entire regulatory system has lost its rhythmic coordination. Every system we've discussed, neurochemical, circadian, autonomic, cognitive, emotional, somatic, needs restoration not just to a rested state, but to proper temporal coordination. This is why sleep alone doesn't always fix exhaustion. You need multiple systems to rediscover their proper timing relationships. This restoration happens gradually through consistent support of natural rhythms, regular sleep-wake times, predictable meals, movement, social connection, light exposure. Each consistent input helps your various systems re-entrain to each other. Recovery isn't about one night of good sleep solving everything, but about weeks of consistency, allowing dozens of systems to resynchronize. Compassion fatigue affects your relationship with yourself. Healthcare workers experiencing repeated exposure to others' suffering develop compassion fatigue, losing ability to maintain empathy. You can develop this toward yourself. Repeated nights of struggle deplete your self-compassion, creating harsh internal dialogue. Your exhausted mind, frustrated by its failure to sleep, becomes your critic rather than ally. This internal harshness creates additional stress, more arousal, worse sleep. Research on self-compassion interventions shows that treating yourself with kindness, speaking to yourself as you would a struggling friend, reduces stress physiology and improves outcomes. Your exhausted self desperately needs compassion but often receives only criticism. This pattern can be changed, though it requires conscious effort to notice harsh thoughts and deliberately choose kinder alternatives. Rhythm entrainment occurs naturally when systems couple. Pendulum clocks hanging on the same wall synchronize their swings. Fireflies flash in unison. Women living together synchronize menstrual cycles. Your various biological rhythms similarly entrain to each other and to environmental cues when given consistent input. Exhausted wakefulness represents loss of entrainment. Systems running on different schedules, creating internal chaos. Restoration requires re-establishing entrainment through Zeitgebers, time-giving cues: morning sunlight, regular meals, consistent bedtime, social rhythms all provide timing, information, helping your various systems resynchronize. Your circadian clock needs light. Your digestive system needs regular meals. Your social brain needs predictable connection. Providing these consistent cues gives your dysregulated systems the information needed to find each other again. Re-establishing the coordination that healthy sleep-wake patterns require, the therapeutic relationship in treating insomnia matters beyond specific techniques. Studies show that feeling understood and supported predicts outcomes as strongly as which treatment method is used. Your exhausted mind needs witness, someone who acknowledges the struggle's reality without trying to immediately fix it. Being seen and heard reduces isolation, activates social regulation systems, and provides hope. This explains why support groups sometimes help even without teaching new skills. The experience of being with others who understand, who don't judge or minimize your experience, allows your social nervous system to begin relaxing. You're not looking for someone to solve your problem, but for someone to recognize it as real and difficult. This validation itself has physiological effects, reducing arousal and creating conditions where change becomes possible. Spirituality and meaning-making offer resources independent of religious belief. Research shows that sense of connection to something larger than yourself, whether nature, humanity, cosmos, or traditional religious concepts, provides psychological resilience. Your exhaustion can feel meaningless, arbitrary suffering. Finding ways to contextualize it within a larger framework, as part of being human, as teacher of patience, as opportunity for growth, doesn't eliminate suffering but changes your relationship to it. This isn't positive thinking or denial, but genuine perspective shift. Your struggle with sleep becomes part of your larger life story rather than defining your identity. Practices that connect you to larger perspectives: meditation, nature exposure, art, music, ceremony, can provide psychological resources. When direct sleep interventions plateau, energy follows attention in subtle but measurable ways. Neuroimaging shows that repeatedly directing attention to body regions increases blood flow and neural activity there. This isn't mystical. It's neurovascular coupling, applied to exhaustion. This means your attention patterns influence your state. Constantly monitoring your tiredness, checking how you feel, focusing on inability to sleep directs energy toward arousal systems. Alternatively, directing attention toward calm sensations, relaxed muscles, or neutral external focus reduces energy flowing to arousal networks. Your exhausted mind naturally monitors for sleep, creating attention patterns that prevent it. Learning to redirect attention gently, without force or judgment, offers another pathway for change. Not forcing yourself to think positively, but simply choosing where to rest awareness. Memory reconsolidation offers hope for changing deep patterns. Neuroscience shows that retrieving memories makes them temporarily unstable, allowing modification before reconsolidation. Each time you remember past sleepless nights, that memory becomes briefly editable. If you can experience something unexpected during retrieval, perhaps accessing the memory while feeling calm rather than worried, the memory reconsolidates with new emotional tone. This suggests that simply remembering past insomnia while in a resourced state might gradually reduce the emotional charge those memories carry. your brain's expectation of sleep difficulty partly stems from memories of past struggles. Systematically revisiting those memories in new contexts might weaken their grip, allowing new possibilities to emerge. This process happens naturally in successful therapy, but can be supported through deliberate practice. Hormetic stress describes beneficial challenges that strengthen systems. Exercise, cold exposure, fasting, all create mild stress that triggers adaptive responses, making you stronger. Could exhausted wakefulness offer similar opportunities? Research is mixed, but some evidence suggests that struggle with sleep can teach valuable skills. Distress tolerance, present moment awareness, self-compassion, patience. These capacities, once developed, serve you in areas beyond sleep. This doesn't mean exhaustion is good for you or should be desired, but perhaps it needn't be entirely negative. Like physical therapy after injury, the struggle of recovery develops strengths that wouldn't exist without the challenge. Your exhaustion might be teaching you things that serve your larger life, even as you work to resolve it. The concept of recovery is itself worth examining. What does recovered mean? Never experiencing sleepless nights, always falling asleep quickly. These standards might be unrealistic. Even excellent sleepers occasionally struggle. Perhaps recovery means returning to average sleep patterns, accepting occasional difficulties without catastrophizing. Or perhaps it means maintaining well-being regardless of sleep quality. Research on insomnia recovery shows multiple possible endpoints. Some people resolve sleep difficulties completely. Others improve substantially but maintain some vulnerability. Others report sleep remains imperfect, but their relationship to it changes so dramatically that it no longer impacts well-being. Your goal might evolve as you progress. Initially, you might seek perfect sleep. Later, you might recognize that resilience matters more than consistency. Integration of insights matters more than accumulation of knowledge. You've absorbed dozens of facts about exhaustion and sleep. Simply knowing these things changes nothing unless knowledge transforms understanding, which transforms behavior, which gradually shifts physiology. The journey from intellectual knowledge to embodied wisdom requires time and experience. You might understand that trying to force sleep is counterproductive, but still find yourself trying. This doesn't mean you're failing. It means you're in the integration phase where new knowledge hasn't yet become automatic behavior. Be patient with this process. Each time you catch yourself in old patterns and choose differently, you strengthen new neural pathways. Integration happens through repetition and lived experience, not sudden insight. We've integrated new understanding. Exhaustion keeping you awake isn't a simple problem with a simple solution, but it's also not unsolvable. Multiple systems contribute to the problem, which means multiple entry points exist for intervention. Your task isn't finding the one right answer, but consistently supporting your nervous system's natural regulation through many small actions. No single night's sleep or wakefulness determines your trajectory. What matters is the overall pattern over weeks and months, gradually establishing consistency, building regulatory capacity, strengthening systems that promote rest. Your exhausted mind and body possess inherent healing capacity. Your role is supporting that capacity, not forcing outcomes. This approach requires patience but offers sustainable change rather than temporary fixes. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Your breath. Inhale. Exhale. Inhale. Exhale. A small cycle within the vast universe. You are also part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order. Like planets silently rotating in their orbits. Unhurried. Unresisting. Simply existing. We're almost there now. Sleep is ultimately a letting go. A surrender to unconsciousness that requires trust. You trust your body to continue breathing. Your heart to keep beating. Your unconscious mind to maintain vital functions. Exhaustion often stems from inability to trust this process. Your nervous system, perceiving threat, believes vigilance is necessary. Learning to sleep again sometimes means learning to trust again. Trusting your body. Trusting the night. Trusting that tomorrow will come regardless of how well you sleep tonight. Every system in your body wants to sleep. No part of you benefits from sustained wakefulness. Your cells need rest periods for repair. Your brain needs sleep to clear metabolic waste. Your immune system requires sleep to function optimally. The wakefulness you experience isn't your body's choice. It's a confused state where protective systems override recovery systems. Recognizing this can shift perspective from fighting your body to working with it. Darkness itself is medicine, independent of sleep. Light suppresses melatonin. Darkness allows its production, even without sleeping. Spending time in complete darkness provides benefits. Your eyes need darkness. Your hormonal systems need darkness. Your ancestral biology expects long periods of darkness that modern life rarely provides. Creating true darkness. Not just dimmed lights, but complete absence of light. Supports your body's natural rhythms. The exhaled breath carries away what you don't need. Physiologically, you're releasing carbon dioxide, metabolic waste. Metaphorically, each exhale offers opportunity to release thoughts, tensions, worries. You don't need effort to exhale. Your body does it naturally. Perhaps sleep is like this. Something that happens naturally when you stop preventing it. Your brain creates models of reality based on predictions and sensory input. When predictions match input, the model remains stable. When mismatches occur, responses to uncertainty result. Your exhausted mind might be predicting danger where none exists, creating mismatches that generate arousal. Sleep requires updating these predictions, teaching your brain that nighttime is safe, that sleep is possible, that you'll be okay regardless of what tonight brings. Chronobiology reveals we are fundamentally rhythmic beings. Heart rate, blood pressure, body temperature, hormone levels, alertness, all oscillate in daily cycles. Sleep doesn't exist in isolation, but as part of these larger rhythms, supporting your rhythms generally. Regular meals, consistent activity, predictable routines, creates foundation for sleep specifically. You are not a machine that simply needs repair, but an oscillating system that needs temporal structure. The Japanese concept of wabi-sabi embraces imperfection as beautiful. Perhaps sleep needn't be perfect to be sufficient. 8 hours isn't necessarily better than 7. Deep sleep's percentage varies naturally. Expecting perfection creates pressure that prevents rest. Accepting good enough sleep might actually allow better sleep by reducing performance worries. Your sleep, like everything human, is imperfect. And that's okay. Ancestors slept differently than we imagine. Biphasic patterns with midnight waking periods were common before industrial light. Historical research by Roger Eckhurch suggests that first sleep and second sleep, with a wakeful period between, were common patterns before industrial lighting, though sleep historians continue debating how widespread this truly was. Perhaps your midnight wakefulness isn't abnormal, but aligned with older patterns. This doesn't mean you must accept it, but it might reduce the sense that something is fundamentally wrong. The body heals in sleep, yes, but also during restful wakefulness. Lying quietly in darkness, even awake, provides significant recovery. Your heart rate lowers, muscles relax, metabolic rate decreases. The gap between restful wakefulness and sleep is smaller than between active wakefulness and restful wakefulness. You're not failing if you're resting peacefully while awake. You're giving your body much of what it needs. Courage isn't absence of fear, but action despite fear. Approaching sleep differently when exhaustion has created fear around bedtime requires courage. Each night you enter your bedroom, despite anticipating struggle, demonstrates bravery. Each time you lie down, knowing sleep might not come, but choosing to rest anyway shows strength. Your struggle with sleep has required courage you may not have recognized. So, could exhaustion keep your mind running instead of sleeping? It already has, through mechanisms we've explored. But this answer is incomplete. The real question might be, given this understanding, what becomes possible? You possess agency even within exhaustion. You can choose compassion over criticism, surrender over struggle, patience over desperation. These choices don't guarantee immediate sleep, but they change your relationship to sleeplessness, reducing the suffering it creates. Your body is ancient, carrying responses evolved over millions of years. Your environment is modern, creating mismatches between evolved biology and current context. This gap explains much of modern health challenges, including sleep. You can't change your biology quickly, but you can modify your environment. Reducing evening light, managing stress, creating routine, working with your ancient body rather than fighting it offers pathway forward. Breath continues, whether you notice it or not. A fundamental rhythm connecting you to life. Sleep, too, happens naturally when conditions allow. You don't create sleep through effort. You allow it through conditions. Physical, mental, environmental. Perhaps your work is less about making sleep happen and more about removing obstacles, preventing its natural occurrence. This reframe shifts from active doing to receptive allowing. The moment between wakefulness and sleep is inherently uncertain. You cannot know when sleep will arrive, cannot control the transition precisely. This uncertainty disturbs exhausted minds seeking control. But uncertainty is fundamental to this transition. Learning to rest in uncertainty, to lie in darkness, not knowing what will happen, might be the essential skill. Not controlling but tolerating, not forcing but allowing. Traditional cultures had rituals around bedtime, prayers, stories, specific preparations. These weren't superstition, but recognition that transition to sleep requires psychological preparation. Creating your own ritual, however simple, signals to your nervous system that transition time approaches. The ritual itself matters less than consistency and meaning you invest in it. Your brain learns the ritual predicts rest. Every cell in your body has experienced the daily light-dark cycle. Your DNA carries instructions for responding to these rhythms, accumulated over countless generations. You are built for sleep. The capacity exists within you, perhaps obscured but not lost. Recovery means uncovering what's always been there, rather than creating something new. The suffering exhaustion creates extends beyond physical tiredness into existential questioning. Why me? What's wrong with me? Will I ever be normal again? These questions create additional pain beyond the primary struggle. You might not have answers to these questions, and that's okay. Sometimes the questions themselves are the problem. Maintaining rumination that prevents rest. Time will pass regardless of whether you sleep. Tomorrow will arrive whether you rest well or poorly. This sounds harsh but offers freedom. Sleep's urgency is somewhat illusory. You've survived previous sleepless nights. You'll survive tonight. This doesn't mean sleep doesn't matter, but it's not the life or death emergency your arousal systems suggest. Reducing the stakes paradoxically makes sleep more accessible. Community exists around insomnia. Millions of people experiencing similar struggles. You're not alone. Even when isolated at 3 a.m., others lie awake this moment, facing similar challenges. This shared experience doesn't solve individual problems, but it challenges the narrative that you're uniquely broken. You're having a human experience, difficult but not unusual. Gratitude practices, though sometimes feeling hollow during suffering, do influence nervous system state. Deliberately acknowledging neutral or positive aspects of your life activates different neural networks than rumination on problems. This isn't toxic positivity, but strategic attention deployment. Your exhausted mind naturally focuses on what's wrong. Deliberately noting what's okay or good provides balance. The real change isn't in sleep patterns, though those might shift, but in your relationship to whatever happens at night. Can you lie awake without catastrophizing? Can you be tired without defining yourself as broken? Can you face another difficult night while maintaining self-compassion? These internal shifts matter more than sleep metrics because they allow well-being regardless of sleep quality. Water flows downhill naturally, not through effort but through allowing gravity and path. Sleep is similar. It happens when you stop blocking its natural occurrence. Your exhaustion has created dams and diversions in sleep's natural flow. Recovery involves identifying and removing these obstacles rather than pushing harder. The water wants to flow. Sleep wants to happen. Your consciousness right now, reading these words, exists in this moment only. The past sleepless nights are memories, not current reality. Future nights remain uncertain, not yet existing. This moment is all that exists. And in this moment, you're okay. You're conscious, breathing, functioning. Present moment awareness reveals that much of your suffering stems from time traveling mentally to past failures and future fears. Hope is not naive optimism, but realistic recognition that change is possible. Your nervous system possesses plasticity. Your body holds healing capacity. Your situation can evolve. Hope doesn't guarantee specific outcomes, but acknowledges possibility. You've survived every difficult night so far. You possess resilience you may not recognize. Tomorrow offers new opportunities to support your system in choosing rest. The ultimate truth transcends sleep advice. You are more than your exhaustion, larger than your sleep problems, capable of well-being even during struggle. Sleep matters. Your body needs it. But your worth doesn't depend on sleeping perfectly. Your identity extends beyond person who cannot sleep. You contain capacity for healing, growth, peace. The exhaustion you feel is real, valid, significant, and you are strong enough to carry it until it lightens. And so, our quiet journey through exhaustion's landscape comes to a gentle close. We've traveled from neurochemical confusion to bodily tension, to the psychological labyrinths where fatigue meets wakefulness in impossible combination, discovering along the way that this state holds its own logic, its own rules, its own pathway toward resolution. From the first fact about tired wired syndrome to our final recognition of your capacity to carry this burden, we've glimpsed how exhaustion is both physiological complexity and existential challenge. This paradox of exhausted wakefulness reminds us that we are not machines requiring simple repairs, but complex systems seeking balance. Much of the wisdom happens in darkness, in quiet moments when we stop struggling and simply allow. Sleep reveals patience, the virtue of surrender, the power of trust. Without accepting our limited control, we exhaust ourselves further through futile struggle. By pausing to notice, by choosing compassion, we glimpse the extraordinary capacity for healing hidden within ordinary human consciousness. In these final minutes, take the deepest breath you can, as deep as possible. Think about consciousness itself, yours, mine, everyone listening, all awareness everywhere, perhaps all connected in ways we don't yet understand. You are not alone in the universe of minds. Let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought. If this thoughtful journey brought you any ease tonight, perhaps a gentle like or subscribe might help another tired mind find their way here too. One quiet tap, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, through the tangled paths where exhaustion meets wakefulness. You can allow these thoughts about sleep and struggle to fade now, like morning mist under sunrise, leaving only the quiet calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity itself is gently pulling you toward rest. If sleep comes, let it carry you like a warm current, smoothly, inevitably, into a realm where tiredness and trying no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, your challenges will still exist. Tomorrow offers new opportunities to support your healing. But tonight belongs to stillness. Rest well, weary traveler. And remember, your worth doesn't depend on sleeping perfectly. You are enough, exactly as you are. In this moment, fall asleep to gentle facts. Dream deeper with bedtime science. Relax, listen, and drift into sleep. Good night.